All right, thanks. So Paul and I are going to kind of tag team this back and forth. Last time we gave this presentation, it was 90 minutes, so I think we'll tighten it up today. But we can certainly be around to talk to people, and we're looking forward to the field trip where we can get into more depth. So we're going to talk a little bit about why rivers and riparian areas are important, in Utah and really around the globe. Human effects on the landscape and how it impacts rivers. And then we're going to drill down, you can see I got my drill up there, on urban stream restoration principles, and really kind of summarize with our watershed approach and kind of how we work from here. So how do rivers, benefit humans? And maybe this is a rhetorical question, or you can think about what are the things that we get from rivers. We talked a little bit about irrigation, drinking water, and river and stream health is part of our water supply, and sometimes we don't think about that. There's a functional flows work group at USU right now that are looking at how much water should be in a stream to keep it a stream, and is it really a river if there's zero water in it? Maybe sometimes. We also talk a little bit about ecosystem health. Biodiversity, fish and wildlife habitat, and water quality are really important to us. If you ever, see a degraded stream and you think, oh, I really am thirsty, you don't really necessarily go and drink the water out of there. So we need to maintain that ecosystem health for that water quality. We also have flood resilience, decreasing the risk of flooding, we're going to talk about, and increasing resilience to climate change. We know we do have these big years, then we have drought years. How do we have that broader suite of services that we can provide? And then human activities. Recreational values is really big, natural heritage, and cooler temperatures in some certain situations. The picture there on that side is actually of Blackner's Bend. Who's been out to Blackner's at the mouth of Weber Canyon? Paul's been there, and some other folks. So that's a restoration project that was done on the Weber. It's pretty cool if you have a chance to get out there. So, we talk a little bit about watersheds, and everyone thinks, oh, watershed, yeah, it's the area that water comes from and then goes down to Great Salt Lake or wherever. But there's a significant difference between the upper watershed in the Weber and the lower. There's a rural component up higher, and then we get down into here and we've got more of the urban areas, lots more roads and impervious surfaces. So the headwaters are significantly different, and they need different management practices, and as what we're talking about today, which is where we're in more of a built environment. And so who here can define a riparian area in one sentence? Maybe nobody. 2 sentences. No. So riparian areas, can be defined as near flowing water with certain type of vegetation, but it does require sometimes humans to come in and say, all right, what really is a riparian area? Where is it here? Especially in urban areas where we've impacted the water so much that they're not really like, cottonwood forests in Montana or whatever. It's different. And so they are near flowing water. They have a certain vegetative characteristic, and generally, part of the floodplain is what we're looking at. And they can vary from a few hundred feet or less, depending upon the ecosystem and the geographic area. So Paul's going to talk a little bit about the human component, but I wanted to mention, I put this picture in the middle on the bottom. Does that look like human-made or natural-made? That was on the Legacy Nature Preserve, and almost all of that was made by humans. It's like there's even a bald eagle nest in the background that a guy named Bob Walter stood back up after it fell down in a windstorm. So, when you add water, it really helps. So Paul's going to talk about the human component.
Sure. So everybody can hear Eric. I don't know if they can hear me. So streams and riparian areas are in urban settings are really important interfaces between people and nature. They can serve as transportation corridors, and this is a really good example of the pathway along the Ogden River. They can provide recreational opportunities, like fishing, swimming, really critical cooling spaces, especially during the summer, and they offer a connection to the natural world among the built environment. Many schools also use these areas as outdoor classrooms, as that picture on the right kind of shows you, giving students hands-on learning experiences in ecology and environmental science. So yeah, really briefly, we've kind of been talking about this quite a bit today, but humans have dramatically reshaped landscapes through land reclamation, expansion of infrastructure, altering natural flow regimes, and all these practices they're really important for society, but they also have major consequences for streams and stream channels and river health. And so this is the same imaginary watershed that Eric showed earlier, but it illustrates kind of the accumulation of the impacts of within a watershed. We're often faced, oftentimes when we're looking at challenges with a river or stream, we're often faced with a site-specific challenge related to a waterway. So, for example, maybe we're dealing with a situation where there's some eroding banks or there's sediment accumulation in the channel. Oftentimes that site-specific challenge is a symptom of larger scale issues that we don't necessarily see when we're just looking at a specific location or specific area. So in this imaginary watershed, there's lots of things going on, right? There's lots of things that might be leading to management challenges, such as headwater management, erosion up in the middle of the watershed. Maybe there's nutrients coming from agriculture or urban landscapes, stream channelization and floodplain encroachment. And they can all kind of accumulate and really affect kind of what we see on the ground when we're dealing with stream channels and urban rivers. So I've got two stories I want to tell with this slide. One is this picture on the left. This is Darren's brush reducing program. This is a railroad bridge on the lower Weber River. From what I can tell, I've done a little bit of research on it. It was built in about the 1890s. And the way it's constructed is you have basically these trestles that are spaced about 10 feet apart. So you can barely get a boat in between them. And during high water, this bridge catches a lot of debris from the Weber River. And the consequences of that are that it backs up the flow. It causes sediment to deposit upstream, and it changes the channel morphology up there. And so when we think about managing specific reaches of river or specific areas, we have to take into account these types of these kinds of things on the landscape, because we're not going to be able to move this bridge, or at least in the near future. And so it's a fixture on the landscape that we have to deal with. Picture on the right illustrates the confluence of the Ogden and the Weber River back in the 1960s. So this is actually a photo of that area in the 60s. The main characteristics here to highlight are a pretty broad riparian area, meandering stream channels. But when you compare that to, this is a Google Earth screenshot, so it's kind of similar. I tried to match it up as much as possible. But so the landscape's changed, right? A lot of industrial areas have encroached on the Weber River. Right in the middle, I don't know. There's probably not a laser pointer. And if I can make that happen. Doesn't look like. Right in the middle, right above the pond, is a large landfill that's been placed right at the confluence of the Weber and the Ogden River. And then just to the right of the pond is a junkyard, right? And those are fixtures on the landscape that we have to deal with when we're looking at river management or river restoration. Those are things that are likely not going to be moved or changed when we do restoration.
So I'm going to talk a little bit about the effects of urbanization on streams and rivers. What are some of the things that happen when we urbanize around these areas? We cut off the floodplains a lot of the time, or maybe we remove the water, and there's something called the urban stream syndrome. The Altered hydrology, I think, is one of our biggest opportunities to like change, because we manage the water, and managing the water in a way that maintains the resilience of these streams is important, because if you just let them go dry and then, there's nothing holding the banks together because there's no vegetation there, it can create a cycle that's a problem. There's also impervious surfaces that increase runoff really fast coming down. We have larger volumes of runoff, peak flows, and the frequency of those flows can go way up if you have a bunch of impervious surfaces. So that was discussed in the Chesapeake Bay discussion earlier. We also have simplified channel geomorphology. When we lose those floodplains, a lot of times the river doesn't do exactly what we want it to do, which is, kind of stay within its banks and things like that. As Paul mentioned, at that bridge, that railroad bridge, the water gets stopped up there because all the debris gets stuck in there, and then it drops a bunch of sediment out just upstream in the Ogden Business Exchange area. So that's just a consideration. And then reduced ecological function can be an issue. Declines in aquatic species and fisheries. A lot of people in Utah really enjoy angling and fishing and getting out into these areas, seeing the birds and other things like that, and getting on the water. And so reduced ecological function is not so good for that. And hardened protection measures is what ends up happening a lot of the time. And so we just want to consider those when we're thinking about what are the tools that we have, where can we make those differences? Can we take out the bridge, or make those spans larger? The railroad said about $1 billion. If anyone's got $1 billion, we can do that. But we really do have to prioritize. This is on the upper right is it's kind of basically a trash collection system on the Ogden River. It works really well to keep a lot of that garbage out of there. And then, so you just want to think about, how do we transfer stormwater to the systems? We create this flashy hydrology. So how can we maybe spread that out a little bit and then reconnect some of the floodplains, so we have that ability to manage these different hydrologies? We've also got impervious surfaces and all the runoff that comes off of those. That's been shown to be a significant source of nutrient pollution, sediment, and garbage, as we mentioned. So there's lots of things that happen in streams, and we want to think about where can we have the maximum effect for doing work on these streams, and how can we get together and have partnerships to do those things. So channel confinement is a significant issue. If you can imagine, when the river is able to flood out into the floodplain, what happens to the sediment? Sometimes it drops out, sometimes it creates floodplains, and it nourishes the system. But then you take away that floodplain, and where does all the energy go? Does it go to the sides? It goes down. And actually, in parts of the Weber River, they think the bottom of the river has gone down as much as 20 or so feet. And so Jake talked a little bit about, floodplain management. And if it's already gone down 20 feet and that's our baseline, and we're trying to go back, it's a tough regulatory environment. So that scour is something to consider, and the sediment transport, and also where that sediment's going to drop out. And I remember that from my youth. I grew up in Virginia, and what happens right at the end of the city? All the levees go away, and then all the sediment drops out, and all the farms downstream had issues. So reduced habitat is another significant issue. So we look at places that we can improve the habitat. And so, places around the state, maybe we've got, bridges are really expensive to put in. And if you put them in wrong and you have to replace them, they're even more expensive. You want to give the river the room that it needs, and sometimes that does require some upfront costs. But those are just some things to consider, because those hydraulic pinch points are some of the most significant opportunities for change, and it creates flooding issues and things like that. Okay, thank you. So we've got 5 minutes left, and Paul's going to talk a little bit about the key principles of urban city.
So there's 5 minutes and 5 principles, so I'll go through. But so really important looking at when we're dealing with an urban stream and dealing with restoration, taking a watershed approach, again, is really critical. And this means not only kind of looking at what's contributing in your upper watershed, but it also includes managing stormwater and trying to replicate kind of the natural processes of infiltration and restoring those natural flow regimes. Second is riparian corridor protection. So Eric mentioned riparian areas a little bit. It's that transition between water and upland. And generally, it's challenging in urban streams, but the wider the riparian area you have, the more healthy, naturally, the more healthy your urban river is going to be. Shooting for 30 feet or greater in terms of width with native species is really critical. Restoring and maintaining these buffers is simple, relatively simple, but it's really powerful in terms of improving urban stream health. Finally, or third, urban stream channels are typically really channelized and straightened, and so reconnecting floodplains, allowing floodwaters to spread out where it's possible, is a really important way of restoring those natural processes within the streams that maintain and restore water quality and habitat. Restoring meanders is really important if it's possible. Again, a lot of these urban systems are really confined, but there are places where restoring meanders is possible. That slows down the water, creates diverse habitats, and then bringing in natural features such as riffles, pools, and even some of the natural woody debris, which maybe some of the flood people don't like, but wood's really important. Wood's really important for maintaining habitat for aquatic species. Development pressures are one of the biggest threats to urban streams, and local governments really can play a key role in balancing growth with stream protection. So there's a lot of things that local communities and local governments can do on the policy side to protect waterways. So that's one of those activities is just knowing and identifying where those sensitive areas are, implementing low impact development strategies to minimize or break up those impervious surfaces, and then establishing setbacks for new buildings and septic systems to prevent contamination and erosion in the urban systems. But restoration isn't just about engineering and policy. It's about people in the community. And research has shown that when healthy streams are available to people, they like them and they use them. And so successful restoration or protection involves local communities in planning and implementation and in long-term stewardship. And there's a lot of different ways to do that. Just a plug for the Utah Water Watch program, which is a citizen science program that really focuses on water quality monitoring in urban areas. That's a great way to engage the communities. So developing goals is really critical. We've been promoting the idea of watershed plans. Engaging partners and stakeholders is really a critical component. So bottom line, this is just a jumping off point for Justin, but it's possible to do urban restoration and provide these spaces for people in places that are really heavily built. And so Justin's going to talk about how that's actually happened. But with that, we'll take any questions.